Can everyone interpret the sketch? You see what's going on there? Box A is sitting on a table. There's a rope carrying some of its upward force. Yeah, it's not just levitating there. Levitating there. The B is lighter than it. So it's going to rest with some amount on the table. From what? From the what? Ropes exert tensions. Okay, you guys need a hint on the first part. No one's answered this, right? This means total force. To find the total force, you follow the steps that I gave in the notes last Monday, and you say, all right, what forces act on the object? What objects are interacting? What kind of force do they interact? Which way do they interact? We don't have numbers, except for the weight, but ignore that. You don't have enough information for numbers, but you can write an algebraic expression in terms of tension, normal, and weight, being added or subtracted up. I'd also like to see those subscripts that I was demonstrating before. First subscript is what is causing the force. Second subscript is what is feeling the force, okay? So when you write a net force expression, what I'm looking for is WT and N added or subtracted together. I'm just saying WT and N because I don't want to give away, and I want you to fill in the blanks of what are the subscripts for those, yeah? 11 symbols long. 11 symbols long. Don't type out paragraphs for me for letter B. For C, what third law pair force to the weight force of Earth on A? Again, you don't need to type out paragraphs. To identify a force, you can write a letter indicating the kind of force, for instance, the weight force, the cause of the force, for instance, the Earth, and the thing which feels the force, for instance, box A. So I'm asking you for what does Newton's third law say? What identify the force using that 3-letter notation. You don't need to write a paragraph. D and E are numbers. Okay. And in particular note, E is not going to accelerate with the values given. I guess I'm adding more weight to B or something. Yeah? Does that make sense? If this guy starts accelerating upward, how much does it weigh? Make sense? Is good? Yeah? Where does it go? Back as you were. Give me those subscripts, Don. That's the thing, Joshua. Good, Aubriana. Good job. Okay, time's up. Show me what you got. If you're not done, it's okay. Give me as much as you got. And I think that's everyone. If you're still typing, type faster. Okay, here we go. D and E, I'm going to work backwards because for reasons. D and E are trick questions. What is the weight force formula? Oh, come on. There are only two formulas you learned last week. What are they? What's the weight force? Mass times gravitational field. Da, comrades. mg is weight. What did I tell you here? What's 10 kilograms mean? What am I telling? This is mass. What's g, gravitational field? 9.8, 10-ish, whatever. Okay. Does that matter if it's moving or not? Weight is mg. You're done. Weight is not ma. Very common answer is people told me mass times acceleration. It's a trap, as Admiral Akbar once said a long time ago in a galaxy far away. ma, again, I repeat, ma is total force on the object. I guess in the example given, that would be tension minus weight. Okay. Don't confuse mg for ma. Weight is a particular force. Weight is always mg. Please also note, if you answered either D or E in terms of kilograms, make a note to yourself, kilograms do not measure weight. You may be used to your chemistry lab instructor saying, weigh the number of grams in your sample, and here I am telling you that is BS. Although I personally also don't say mass your samples grams or whatever. I guess it's not that they are BSing you, it's that our language is BS. That's the point I want to make. Grams and newtons measure different things. And if I ask you for weight, your answer should be in newtons, because that's what newtons tell you, the pull, the gravitational weight force. So D and E should both be 98 newtons. Write that down. Weight force is mg, baby. Don't forget it again. And it doesn't matter what's happening. Weight force is mg, is mg, is mg, is mg. C. We talked about this like a half a dozen times last week. Let's review it. Newton's third law says that one force acts on two objects. That is to say, one force is actually a pair of forces. Is actually, one force has two perspectives. One force, a weight force, acts between Earth and A, and you can either view that from A's perspective, thinking that the gravity is pulling me down, or you could think about it from the Earth's perspective, which by Newton's third law says gravity is pulling Earth up. Okay? The Newton's third law paired to a weight force is never a tension force. Newton's third law paired to a weight force is never a normal force. The kind of force and the objects that are exchanging that force are always the same. If this is a weight, third law pair is a weight. If this is a normal, third law pair is a normal. If this is a, I don't know, flip force, then the third law pair is a flip force. The objects interacting, EA, AE. Same E equals same E, just flip them, baby. And then interpret the weight force, a gravitational interaction that A, the box, pulls upward on E, Earth, with. Deja vu? Is very, very, very common at this point for me still to be people, let me try that word again. It is very common at this point for people still to say that normal force is opposing weight force. Well, that's true, but they aren't third law pairs. What is the third law pair? Anyone? What's the third law pair? We already talked about weight on an object. What's the third law pair to the normal force that the ground exerts on me? The normal force that I exert on the ground. It's the same kind of force, same two objects, just flip the perspective. You see? Watch out for this. This is easier than it looks. Question? Sure. The negative is not implied by swapping the subscripts. I am here asking only for a name, not a number, not a direction. I will very often use the fact that they are in opposite directions. But here I'm just asking what, in other words, identify the opposing force. So what I was looking for is weight force of A on Earth. Hey, by the way, Alex introduced me to this notation, A little arrow E. You obviously can't typeset that if you're typing, or maybe you can, I don't know, go into special characters, whatever. She found that many students helped them remember A is pushing on E. A exerts a force on E. Help them remember what the subscripts even mean. If that helps you, use it. If you just hate typing the right arrow, forget it. The meaning of that is just to remind you, the whole purpose of that is to remind you, A pushes on E. That's what AE means. Okay. So I'm looking for WAE. Okay. And the correct answer is, might as well write these out, 98 newtons. 98 newtons. And now the dreaded B. Bees! They're in my eyes. Okay. This is the capstone, the central, the biggest goal for today. I don't want to just tell you. I want to work you up through it, okay? Draw the diagram, draw a sketch of this on your paper, okay? You're gonna need to come back to this. I'm gonna build you through it, walk you through it. please reflect carefully on the steps that we go through, because as I said, I'm going to give you, oh God, what is it? It's actually 4 problems today, and many more on the homeworks and quizzes. I'm going to give you 4 problems right now, and you're going to do the same darn steps every time, just in different ways. So think about what we're doing, why we're doing it. You're going to do the same thing again and again and again. The central key to all of what we're doing is the slide on last Monday's slide set that said identifying forces. And what I'm going to do now is I'm going to break this up. Remember, there's 4 steps. Is there a planet? Include weight. Draw a dotted line around the object. If an object passes through the line, it might exert a force. Consult the dictionary to find the kind of force. Okay? Oh, I want to build that up more because I think people aren't following the steps. Part F, question F. Please identify. Simply, don't write me an essay, in a couple of words, what objects interact with, exert forces on, box A. You could talk to each other for this one. Gesundheit. Don, slow down. Wherever you are. Slow down. Give me the objects that exert forces, not the forces themselves. Okay, put them in. Let me see what you got. Cliff, the table. Clearly a table. Isn't that the best table that's ever been drawn? It's like a Michelangelo would have drawn that table better. No, worse. What you talking about? Foods. Ah, damn it, because normally I am all about that base. Okay, so many correct answers. Not as many as I want. When I say object forced off, how do I define object? What must be true about an object? You have to be able to lick it. If you say gravity, shame on you. Gravity is not a thing you can lick. Remember? When I say object, it must be a thing. Second, other than weight force, every other force is contact force. So we're going to identify objects which touch. Oh, right. Yeah. Hold on a second. Go back. What is the object that exerts long-range force? What object? Earth. Earth exerts weight forces. Huh? I mean, don't. It's dirty, but yeah. You can lick Earth. You can't lick gravity. Okay. So let me ask you this. What passes through that dotted line? The table. And those are your 3 objects that interact. Table, rope, Earth. That's it. Does B interact? B interacts with the rope interacts with A. B indirectly exerts, but I'm going to say no. The B does not touch A. Later on, we'll introduce a shorthand in tensions and ropes. We'll let that happen, but not for now, not until I tell you to do so. For now, you know touchy, he know forcey. Yeah? Okay, so the correct answer for F, earth table. The earth table rope. Okay, questions G and H. Talk to your neighbors. Let's do it in this order. Earth table rope. What is the manner of force? Normal, tension, friction, drag, weight, blah. What kind of force? In that order, I want 3 letters. If it's a weight force, W. If it's a normal force, N. If it's an arbitrary applied force, F. If it's a drag force, D. If it's a buoyant force, B. Yeah? Normal force, N. I think I already said that. So in order, earth table rope. What kind of forces? And then H is what direction does each force act? In that order, earth table rope, pull up, push down, what? Hey, better than the first section. Good. Temperature. What you talking about, foo? I want to emphasize the letter I traditionally use for weight is W. Let's have things consistent so that I can grade these quickly, please. Wait, how did you list 4 things? There are 3 objects. They exert 3 forces. Yo, check yourself. All right, I'm pleased to see you guys are beating the first section. Beat them, y'all. Even though you guys are the tireder section, you're also getting this right. Weight, normal, tension. WNT is what I was looking for G. Okay, questions. Why is it weight? Well, it's a gravitational force. Exactly. The Earth as a whole, notice, is not touching box A. The only way planets exert forces as a whole is through their gravity. Their weight forces. Why is the table experiencing and giving a normal force? What's a normal force? Does it mean an everyday ordinary force? Solid-solid interaction at right angles to the interface. That's what normal means. Okay. Note, which direction does the normal exert? Point for me, point. Whole class at a time. Point normal force. Good. Only about half of the 3 o'clock class got that. You guys are on fire. Up. Note, please note. This may sometimes be a challenge. Here is a rule for you. Write this down. Normal force exerted by an object always points away from that object. The table exerts force upward on the box that's above it. Third law says that if Earth pulls box, box pulls Earth, and that does not belong on the first diagram. It does not belong on A's diagram.
Oh, so it's not about the force that A is on.
What is the table doing to A? When you are analyzing A, it's all about A. Don't think what A is doing. You're absolutely right. A does do stuff to other objects. You consider them separately. When you're focusing on A, only ask what A gets. Be very self-centered. Imagine yourself as A, and the whole world's about you. Okay, did you all write that down? Normal forces point away from the object. I mean, think about the opposite. Think about what it would mean for the opposite. If the table is exerting a downward force on A, it's like suctioning A, sucking it into itself. Is that the way that normal forces act? No. Okay, which way does a tension force act? Always. Not always up. I could exert a downward or a sideways tension. Towards what itself? No. What you talking about? Towards what self? Look at the direction of the rope. Write this down too. The direction of the rope shows the direction of the tension force. Hmm. 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 I'm going to exert a tension force on this purse. I'm going to exert a tension force that pulls this purse to the right. Watch as I utterly fail to exert a tension force when the rope is up, strap is up down, that pushes us to the right. Nope, purse is not going rightward. Yeah? Which direction is the purse going? Watch as I exert a downward force on the purse. Oh, no, that didn't work. No. Ropes suck at exerting sideways or push forces. You can always find the direction of a tension force by looking at it. It's the same way that the rope is leaving. If the rope is going up, then the tension force is up. Capiche? Common sense? Yeah. Nope. The Newton's third law of tension force acts on the rope. Rope pulls on A, then A pulls on rope. Is not saying that two forces act on one object. That's true. That's true. Okay. Which direction do the forces act then? No. Question first. You tell me. I'm A. Which direction is the rope leaving me? Is it leaving my hair or is it pulling on my feet? Where is the rope going? You're box A. Do you feel it pulling this way or that way? Which direction is the rope headed? Pulls up. Again, rope tensions. Tension forces are always in the direction of the thing exerting the tension. Ropes suck at pushing. Ropes suck at pushing sideways. They pull along themselves along the direction of motion, along the direction of rope. Okay, so it's identified the direction of Earth's weight force, table's normal force, and rope's tension force. Up, down, down. Let me try that again. Down, down, up, up. Turn to your neighbor and discuss. Down, up, up is the correct answer for H. Got a lot of correct answers, but not everybody. Weight force is exerted between Only a question or 10 hanging around the room. Ask me a question before we move on. Several individual people have asked me goodly questions. How about questions for the benefit of the class? No? Really no? Okay, now let's put the puzzle pieces together. Well, hold on. What kind of forces do these exert? Exert weight, normal, tension. Weight is down, normal is in this case up, tension is in this case up. Here's my free body diagram. I have 3 interactions. I've suppressed the subscripts for the sake of brevity here. Normal and tension are up, weight force is down. Let me tell you a story briefly. I walked 500 miles. I walked 500 more. Then I got sick of knocking at your door and I walked back 200 miles. Where am I? 800 miles from where I started. How'd you do that? 500 plus 500 minus 200, sure. Okay. If I go up a distance x, and then I go up a distance y, then I go down a distance z, how far am I from where I started? How could I calculate that? Give me an expression in terms of letters. X plus y minus z. I have 2 up forces and a downward force. Question I is tell me an expression in terms of those 3 letters. Tell me a mathematical expression for the total force on this object. This is question A again, all over again. I want an expression for total force on this object in terms of NTW. It should be a very short sentence. Very short entry. Give me net force again. This time right. In other words, tell me I. Oh my God, look at all those correct answers. Oh. Okay, so just, I want you to apply this for a second. Check your answer. If this is 500 and this is 500 and this is 200, your answers should compare with the correct answer of 800. Try plugging in t equals 500, n equals 500, the w equals 200. Is your answer 800? Double check yourself. I will walk 500 miles. I will walk 500 more. Then I will get sick of knocking at your door and go back 200 miles. Do your numbers add up in your expression? So if you have n plus t plus w, are you actually 1,200 miles away? No, 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 as my son said. Not a number, not a number, not a number. I'm looking for an algebraic expression. I'm using numbers to help you reason about what you wrote. So I'm looking for an algebraic expression involving n, t, and w. No numbers, please. Alrighty. The correct answer is n plus t minus w. Again, the correct answer. Net force in the vertical direction is normal force up, tension force up, weight force down. Now, what is the net force for this object? Zero, how do you know? So if you wrote W minus N minus T, doesn't actually matter. I want you to think about this. Which direction do I normally associate with positive? Or up and right, yeah? Positive Y, positive X directions. So I think if you wrote W minus N minus T, what's got you so down? Stay positive, everyone. N plus T minus W. Questions about this? Not just the pun. Yeah. No. Total. Total force is zero. He's not accelerating. I told you it's just sitting there at the beginning. Don't look at, close your eyes just for a sec. I wrote the answer up here. Okay, you can open. Okay, so here is the next problem. We are going to discuss the total force acting on a pad of paper. I'm going to say, let me include a little thingity thing here. I'm going to analyze friction. No, you don't need to know a darn thing about friction. But I am going to tell you that the surface of the notebook, the notebook is, surface of the notebook has some friction. I'm going to ignore the table's friction for the sake of not making this too long. So the table friction is ignorable. My hand is going to exert a sideways big force on the pad. Hand on pad is going to be to the right from y'all's perspective. There is a notebook on top. I want you to reason about what direction, what force acts on what. Okay? Our goal is to write the total force on the pad in both the vertical and horizontal directions. Do the same steps that I just guided you through one by one. Identify objects, identify forces, identify directions, draw a diagram with ups and downs. Your goal, the first goal, is for you to write an algebraic expression for the vertical net force, okay? Give me the vertical net force. That means we can ignore friction for this. So this will be answer K. Okay? K. J. I can't count. JK. LOL. Is good? Is good? Follow the same damn steps. It's the same thing. Not exactly, but. Oh, to enter this, if you have more than one force of the same type, use subscripts. So I could tell what's causing it. Yeah? Does that make sense? If you got two tensions, for example, don't just call them T and T. Call them, T left and T right. If you've got two weight forces, weight force of the Earth and weight force of the Moon. TETM, WEWM. Is good? Pad. And again, we're talking about the pad. It's all about the pad. We'll talk about the notebook and table in hand later. Give me the pad total. Oh, and talk to your neighbor. It should be louder in here. Help each other. Gesundheit. Notebook on pad on table. And then later my hand's going to act horizontally, okay? You can visualize it? Okay, there are a lot of wrong answers trickling in. Let me strongly encourage you, look at the order we just did the steps 15 minutes ago. Identify what objects are interacting, how are they interacting, which direction are they interacting, then write your algebraic expression. Don't jump finally for an answer. I think too many of you are guessing. Do the steps with each other. Where's that go? Vertical. There are getting to be a lot of right answers here, but there are also a whole bunch of wrong answers. Please check the people on both sides of you. Make sure that you discuss the steps, not just your final numbers, final expressions. All right, so we're at about 50% of the class getting this right here. All together, let's walk through the steps. What is step uno that we've been doing? Already drew it. What did I identify first? What did I talk you through very first? No, not the forces, the objects. What three objects interact with pad in the vertical direction? Talking about vertical here. Notebook, the table, the earth. Great, those are the vertical things. Notebook, table, earth. You should have three things. If you draw a dotted line around it, there are only three things acting up, down. Yeah? What kind of force do planets exert? Good. You should have weight force involved. Of, on, good. Wet. Okay. WEP, weight force of Earth on pad. Great. What kind of force does table exert? Which causer? And of what? What's the first subscript? Table. Second subscript? Pad. I had a couple of people at and PT. That would be what the table feels. And TP is what the pad feels. So second force and TP. Hey, which direction is the table pushing on the pad? Positive, upward. Which direction is the weight force of the Earth on the pad? Downward. Follow-up question. No. Last one. What's the last object? The notebook. What kind of force is this? Is it weight? Is it weight? What exerts weight forces? Gravitational is not a thing. Planets and stars and your mama. The trick is at least one of the objects has got to be astronomically massive. Write this down. Weight forces. Here's how you can identify what exerts weight forces. Planets, stars. You can write your mama if you want to. At least one of the objects must be astronomically large. Why doesn't the notebook exert a weight force on the pad? It's not astronomically large. Now, I will admit to you that if that notebook weighs 10 newtons, then the normal force of the notebook on the pad will be 10 newtons. But it's not a weight interaction. It's a touch interaction. It's a solid-solid interaction. What kind of interaction is solid-solid? Don't say weight. Weight force of? What are the subscripts? The Earth exerts a normal force? I'm talking about the notebooks. The notebook pushing on the pad. N of NP, NNP. Okay, so we have now built up to, there are three forces acting on there are three vertical forces acting on the pad. There's WEP, there's NTP, there's NNP. We reason that the table pushes up, the Earth pushes down. Which direction does the notebook exert a force on the pad? Down, are you sure? Okay, normal forces can act downward, is that right? But so often there's an upward normal force. What gives? Okay, what did I have you write down earlier about normal forces? Normal forces do what? Push away from the object. Notebook's on top, you push down. Yeah. Don't fall into the trap that just because we often have an upward normal equal to something's weight, that's often true, that is not a universal truth. Okay? So your diagram should look like this. There is a downward weight force of Earth on pad. There is a downward normal force of notebook on pad. There is an upward force of normal of table on pad. The correct answer, NTP minus WEP minus NNP. Turn to your neighbor and discuss what the heck did Tucker do and why did he do it, and then I want some questions. I hunger for your questions. Wait, hold on. I want your questions, but I want people to think about it first. So don't forget it. I want your question, but I want people to think about it for a minute first. All right, that's time. Please pay attention to your classmates. I want 3 questions. Okay, so first question is, can you add the downward forces and subtract them from the upward force? Can you add these two in parentheses and do NTP minus wet plus NNP? Let me put this to experimental arithmetic. What's 12 minus 3 minus 5? Think about it. 12 minus 3 minus 5. How do you do that? 12 minus 3 plus 5 is 8, right? 3 plus 5 is 8. 12 minus 8 is 4. Yeah. Okay. What happens if we do 12 minus 3 minus 5? Samey equals samey? Does that always work? It's called the associative principle of arithmetic. It always works. Yes, you could do all downs minus up minus all downs. All ups minus all downs, sure. You can group them. Totes. Question. Same thing. So the order does not matter. But what is this? Commutative principle of addition. 5 plus -2 is the same thing as -2 plus 5. Always. Till you get into group theory and math 597 or whatever it is. Anyway, you don't want to do that. Or is that abstract algebra? Whatever, doesn't matter. Okay, so I want some feedbacks. No, that was 2 questions. Give me a third. I hunger for a third question. Your third question. Yeah, give me a third question. This is an equal sign. This is a minus sign. This is a minus sign. They're down. We subtract them off. But like I was discussing arithmetically, 12 minus 3 minus 5 is equal to 12 minus 3 plus 5. You can absolutely, it is arithmetically equivalent to add 2 things up and then subtract them off. It is the same mathematical thing, always and forever, I guarantee it. But like, there's no difference between these expressions, so I just wrote one, and if you wrote the other, then yeah. Sure. Okay, so we have done the vertical case. I want some more feedback though about where you guys are screwing up, because I gave you the problem without any help, and I think 90% of you missed it. More? And then I walked you through step by step. Here is step 1. What objects? What kinds? What directions? Build it. And I think about 90% of y'all were getting most of the steps there. Got to the final layer, build it all, and then I think it was like 95% of y'all. Then I gave you no scaffolding, asked you equivalent, the mathematically identical statement, 2 ups, 1 down, or last I had 2 ups, 1 down, whatever. And then we're back to 50% of you getting this right. So, question K. It's got to be one of the following 4. It's got to be one of the following 4 steps: identifying objects, identifying type of force, identifying direction, or adding things up with appropriate minus signs. Please tell me what's hard. Where are you struggling? What's giving you kittens, as my godfather would have said? We're going to do that in a minute. First, I want some feedback about where people are still struggling. You must have dropped out in one of those steps. Yeah, I have a vote for direction. I have a vote for type. I have a vote for somebody doing some different problem. Which forces are being exerted? Identifying. Feel better. Okay, good. Direction. Type. Oh, those 4 are definitely type. Okay. I mean, I want to get full results in. I shouldn't jump ahead. You are good. Aw. All right, thank you for your feedback. We're still 50-50 on type and direction. Looks like the big things. Here's the shortcut for type. We've only been dealing with 3 forces right now: normal, weight, tension. Right? Right? I'm not forgetting. Normal is 2 hard things pushing each other. Tension is ropes. Weight is planets. That's your kind of forces identifier. You ask yourself, what is exerting them? If very few people said identifying objects. So if you know the object that exerts it, think about it. Am I a planet? Am I a rope? Am I a hard thing pushing against? There you go. The other is direction. The shortcuts for direction are weight, down. Weight force of Earth on anything is down. Tension along the direction of the rope. Normal away from the surface exerting. Does that help? Smidge? Más o menos? Before we are done, before we go, I want to hit the horizontal. There is a new kind of force. There's a new kid in town. His name is friction. This is the entire subject of next lecture. I'm not going to tell you let me try that again. I'm not going to tell you the laws of friction. I'm not going to tell you the formulas for friction. You don't need that to do the following problem. We're going to analyze the force of friction just based on experiment. Watch carefully. I have lined up the composition book so that his edge is even with the edge of the table. Can you guys see the book here? Can you see the book in the pad of paper? Watch in awe. Okay. I want you to discuss with your classmates. Tell me the direction of the friction on the notebook. Next question, whatever the hell we're on. What are we on? L. What direction? This be right, this be left. Which direction was the friction on the notebook? It is yoink. It be yoink. That's my baby. Lately, his default movement is bang to everything. Huh? 13 months now. 13 months tomorrow. And you're what? No, that's Nalo. That's Nalo when he was 3. My older son, he's 8 now. Actually, when he was 4. Yep, that's Nalo. Nalo break. Just a smidge. And again, the question is, which direction is the friction force? Let me ask you a follow-up question. What other objects interact horizontally on the notebook? The hand does not touch the notebook. The hand pulls the pad. Which other objects touch the notebook? Gravitation points down. Can be horizontal objects acting on notebook. Pad. What's the net force on the notebook? Right or left? Which way did it accelerate? Are you sure? It moved right. Yeah, it was stationary, then it picked up a rightward velocity. Yeah. Which direction is the friction force on the notebook? Or are you telling me left? The net force is to the right. There's only one force. It's got to be to the right. Yeah? Think about it. Think about it. Now, my suspicion is that many people are weirded out by friction helping motion. Is that weird? Friction causing the motion? Very often in physics problems, friction opposes the direction of motion of the object. That is not a universal law. Think about it, think about it, think about it. There's only one force acting horizontally on the notebook. The net force is rightward from y'all's perspective. The direction of the friction force has to be rightward. Write down an expression. Let's call the hand force a tension. Oh, that's sort of silly. I don't know, maybe I am skinny enough for this to be a rope. Okay, so let's write down oh, for dog's sake, an algebraic expression involving the tension force of hand on pad and the friction force, call that F, friction force of notebook on pad. We're ignoring the table. I'm saying the table is slippery, slidery, and I want you to write me an algebraic expression for the force of for the total force, the net force in the horizontal direction involving those two components. Is good? Is good? Where's that go? The pad is what I'm talking about now. I'm talking about your pad. The pad. All about the pad. Ooh, that's 50-50 left, right. Okay, question M again. Give me a net force expression. Net force on the pad in the horizontal direction in terms of tension and friction. Weight does not act vertically. Normal, weight and normal should not appear in your expression. Those are vertical forces. H, what's H? Pad, 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 pad. We're talking pad now. Notebook was N. Now we're on pad. Oh, H is hand. Of course, I'm so silly. Herp, derp, burp, burp. Nah, you can ask me now. I don't.